Okay, this is how we are going to manufacture iron. We are going to manufacture iron from its oxide ores, hematite and magnetite. Hematite and magnetite are the ores of the iron. Ores of the iron are what? Hematite and magnetite. Both are oxide ore only, so directly we can reduce it to the metal. But only thing what we are going to do, we are going to do the reduction in one place. What is that place? That is the blast furnace. This is what the blast furnace. Okay. So this is the topic which you cannot study from the theory book and understand. It needs some practical explanation because the sequence of reaction, place of the reaction, purpose of the arrangement, everything is not need to be studied chronologically. Until unless you don't study chronologically, you cannot understand. Okay, so that's why this topic is to be gone through the video lecture only. Just studying through the notes may not give you the good marks because of the chronological arrangement. Like this diagram will be there, so but from the diagram which is to be studied fast and what is the purpose of each and everything, it will be difficult for you. Okay, so this is how the arrangement, this arrangement which is appearing at the top, this is called as a cup and cone arrangement. Okay, this is the most neglected area by the student but interested area by the examiner. Cup and cone arrangement. Okay, what is cup and cone arrangement? It is a special arrangement used for feeding the blast furnace with the charge and avoids escaping of the hot air and proper material, valuable material during addition of the charge. Okay, when you add charge to this blast furnace, hot air should not go outside, which will be economically very difficult because we are losing the heat to the atmosphere. It also causes the pollution and also increases the expenditure. So to avoid that, this cup and cone arrangement. Once charge is fed, it is closed from the bottom. Okay. Once it is lifted, then only charge can come and the hot air exit is closed. Okay. The hot air exit is closed while feeding the charge. Okay. So that is called as a cup and cone arrangement. Main thing you should remember that cup and cone arrangement is a special arrangement which takes care of the loss of hot air during the addition of the charge. Okay, that is one place we have to be very careful. Second thing, charge. Here, second thing is what? Charge. Here, charge means it is not the positive and negative charge. It is not the positive and negative charge. It is a charge is a mixture here. What is here? Charge is a mixture. Mixture of how many things and their ratio is important because nowadays the integer type questions are on the rise. Therefore, wherever some integers are there, you have to remember them specially. Charge is a mixture of 8 parts of roasted ore, 1 part of limestone, and 4 part of coke. Okay, 4 part of coke. Is it understood, all of you? Any doubt about this? Okay, see, this is the this arrangement purpose. This is the charge we are going to feed. Now the question will be, Now the question will be how the temperature is so much variation, how much, why this much temperature is maintained. Okay. So for that maintaining this is the hot air tires, TUYERS. Okay, hot air tires. They will continuously blow the hot air. What are these? They are the continuously blow the hot air into the system of blast furnace. Okay, hot air tires. Okay, so this is indirectly giving the oxygen, and from the top, what we are giving? Roasted ore, and that means roasting is done, FES2. Sometimes what we can have the FES2 also. So for that roasting is done, that roasting calcination is there. So everything is need to be converted. If any chance of the sulfide ore is there, to avoid that is to invert present in the sulfur form, it is need to be manipulated to oxide ore, for that roasted ore. Now roasted ore is mixed with limestone. And what is limestone? Limestone here it act as a two parts. It provide the carbon dioxide and it will provide you the another thing which is called as a flux. Okay, what is the flux? I will explain. Don't worry, here I will explain. Okay, so limestone will provide you carbon dioxide and flux CaO. Okay, CaO is provided by the limestone and CO2 is also provided. What is the purpose of CO2? That also I will explain. What is the purpose of CaO? That also I will explain. And coke. So when they study initially, when the question comes, what is the reducing agent used in the blast furnace? So what they will see here, coke is added, so coke they will write. But the question is minute change. See, if the question is what is the reducing agent added in the blast furnace, is coke. Which substance act as a reducing agent in the blast furnace? Both appear to be same or not, but answer is not same. We are adding the coke, but coke will not directly add as a reducing agent. Will carbon monoxide will act as a reducing agent. Okay. So first we are adding coke, but this coke and CO2, this atmospheric CO2 or this CO2, CO2 plus C will convert into what? CO. So that carbon monoxide will act as a reducing agent. Okay. That's why very important to go through the guidance from a experienced teacher, so that where the examiner is going to confuse you with the magic of words. If question is what is the reducing agent added in the blast furnace, what will write? Coke. If the question is which substance act as a reducing agent in the blast furnace, we are adding this, but CaO is acting. Is it understood? So, and try to study between the lines. This is what called as in English reading between the lines. Reading between the lines means if you understand only that sentence meaning, you are reading only that line. So internal meaning, if you are studying, reading between the lines. Okay. So coke, limestone, and that's way. Okay. CO2. Now see why this temperature is lot of variation. Why hot here? Why cold here? Why? Because we are giving the oxygen. This is a combustion zone where the charge coke from the charge and oxygen from the hot air tire will react with each other. C from the charge, O2 from the hot air will give you the CO2. This is an excellent combustion reaction. Sometimes if oxygen is less, then it can result in carbon monoxide also. Okay, this is also combustion reaction only. Combustion reaction is always exothermic reaction. Which reaction? Exothermic reaction. So it is going to provide you with the heat. That's why this much hot temperature is maintained. Okay. Now when it goes top, see here temperature is reduced or not. This is called as the zone of fusion. Why it is called fusion? Because actually, frankly speaking, iron is manufactured here itself above this zone only. Okay, but that solid iron will come to this zone and converted into liquid after this zone. After the fusion zone, what it will be done? Liquid. Up to here it is solid. After this it is liquid, and it will trickle down. What down? Trickle down. That word you have to be very careful. Trickle down means dropping slowly, and it will fall over here. Okay. So this is the molten iron. Molten iron fall over here. Understood? Now see how much dangerous it is. Here our entire iron, after lot of efforts, we could collect the iron, and this cunning oxygen is going just by nearby. If sometime if it feels like reacting with our more reactive iron, oxygen is here, iron is here. What is here? Oxygen is here and iron is here. So there is a chance of reaction of this oxygen from the hot air or molten iron. So for that a protective layer will be there. What will be there? Protective layer. What is that protective layer? That protective layer is CaSiO3. What is that? CaSiO3. What is CaSiO3? That is slag. What is this? It is the slag. Okay. So sometimes we will feel that it is not used. Even a stopped watch will give you the time two times, correct time two times a day. Is it or not? That is the same thing with the slag. Okay. Slag, we feel that it is a waste material, but it is giving you the two uses. How many uses? Two uses. The waste slag can useful two ways. How many ways? Two ways. We will feel that watch is not working, but it will give you time how many times in a day? Correct time how many times in a day? Two times in a day it will give you the correct time. Suppose it stopped at 9 o'clock. So it will show the 9 o'clock correct time two times, morning 9 and evening 9. Okay. Likewise, this lag also will give you two uses. What is that? It will protect the molten iron by for reacting with oxygen. If oxygen want and says, I wanted to react with molten iron, he will say no. Before reacting him, I am there to protect him. So iron is protected by the slag. First use. Second use is it is used in the fertilizers. Where it is used in the fertilizers. Okay, CaSiO3, calcium silicate. Now that much beautiful substance, even people consider them as a useless, still it is being used. So such formation is explained here. Limestone on decomposition will give you the CaO, and this is called as what I told you, flux. And the impurity available in the ore is SiO2. This is called as a gong. Okay, so this we are deliberately adding. Our intention is to remove him. They both will combine together to form CaSiO3. So this is how the generation of CaSiO3 is done. Okay. First thing, it will remove the impurities and formed. So it will protect the molten iron we prepared. Before collecting only, sometimes it may react again, it will convert back to the Fe2O3 or Fe3O4. So that is avoided by the slag and it can be used in fertilizers. Already it has done its work. What is that work? It removed the flux, gone. Okay. So now this is why this high temperature here, is it understood? Now that the heat, when it goes here, some heat is used in melting. Okay. Then some more heat will be used in heat adsorption zone, where it will convert the impurities like sulfur is there. Sulfur will be converted to sulfur dioxide. Okay. Phosphorus is there, phosphate. And some reduction process also will go, like carbon dioxide plus carbon monoxide. Actual that reaction will be here. So this reduction, once combustion or oxidation is a okay, once combustion is a oxidation where it is exothermic, obviously reduction must be endothermic. Okay, it will reduce the temperature. What is the reduction carried out here? Carbon from the charge, carbon dioxide from the limestone. Both will react with each other to form CO. So carbon dioxide is reduced to carbon monoxide. Okay. Now, meaning of the flux and slag. Again, I am explaining this area of zone and along with the reaction. I think it is understood now. Okay. So I will give you the reactions also. Don't worry about that. So should I erase this one? I am going to explain in detail about the flux and gong. Okay. What is the flux? What is the gong? What is the slag? And what is the selection of it? Okay. CaO plus SiO2 will give you the CaSiO3. This is the complete chemical reaction. Mathematically, if I wanted to write, mathematical relation will be the substance which is added to remove the impurity is called as flux. And this is the substance deliberately added. Okay, this we are adding. And our intention is to remove impurity. What is that impurity? Is called as a gong. Then this flux will directly go and pick up the gong from the impure metal and it will form as a infusible material that is called as a slag. What it is called as? Infusible means it will not mix, it will float. Okay, infusible means, is it understood? It will float over the liquid. That's why it is called as a infusible and it is slag. Flux plus gong will give you the slag. So before adding, we should check out the what type of gong is present. Suppose gong is base, okay, and we are also adding base. What is the use? Because base will never talk to base. Always opposite attracts. Is it understood? If you want some person to send to the base, it should be attractive acid or not. So that time we should select the attractive acid. Okay. So already, if already impurity is like here, acidic impurity is there. That's why I have selected a base. Is it understood? If already attractive acid is there which we wanted to remove, then we will add the base. So we cannot send a acid to another acid. Okay, they will not talk with each other. They will not react with each other. Acid can never react with another acid. Always they will make a what do you call? They will make a war only. I am better acid, you are better acid, but there is no use of it. There is no product of it. If you want a good product, always react the opposite things. Acid is there, react with base. Reducing agent is there, react with the acid. Okay. Likewise, always you should select the opposite part of it. Is it understood? Now this is salt. Simply we can say acid and base, whatever we are getting is a salt. That way you can say it as a salt. Okay. So is it understood now? Any doubt about this? Okay, in the previous screen, I have by mistake, I have forgot to write I here. CaSiO3, not CaSO3. Okay, calcium sulfite is not. Calcium silicate, CaSiO3. Is it understood? Let's see the some reactions in the different zone. Okay, first one is combustion zone. As the suggest, it converts the, if oxygen is less, then 2 moles of carbon with react with the oxygen to form carbon monoxide, but it is less amount of heat will be liberated because it is a partial combustion. But the same carbon when react with more oxygen, see, more complete combustion, 97 kilocalorie. Understood? So high temperature is caused by this complete combustion. Now fusion, I told you, when it trickles down from the top, it converts from solid to the liquid. That's why it is called as a fusion zone. Okay. Heat absorption. Actually, this heat is liberated here because of the heat absorption. The temperature is lowered. Manganese oxide is reduced to manganese. Sulfur dioxide reduced to sulfur. Silicon dioxide reduced to silicon. Calcium phosphate decomposed to calcium oxide and P2O5. Okay. So this reaction is not balanced. Only thing is to show you intention that reduction is done. Our main heart of this reaction, importance of this reaction is here. What is that? What is that importance? Conversion of oxide ore into the metal. Okay, the entire process is for this one only. All are the side reactions. All are what? Side reactions. Is it understood? Any doubt about this?